Hello everybody and welcome to our first lesson in Unit 5 on roots and radical functions. Today's topic is on simplifying radicals, and our objective is we will add, subtract, multiply, divide, and simplify radical expressions, and we will write radical expressions as expressions with rational exponents. In order to do that, we need to remember the properties of radicals that we have met the first time in Algebra 1. But before we even get started, let's review some vocabulary. Let me give you an expression like this here on the side. And let's discuss the different parts. The 4, which indicates to us which root we are taking, is called the index. This boxy thing, which almost looks like the house that we built for long division, is called the radical, and the expression underneath the radical is called radicand. Those 3 parts of a radical expression we need to remember because we will use this vocabulary going forward. So let's talk about the product property. The product property says that if we have the root of a product, then we can split the product apart into its factors and take the root of each of the factors. The nth root of a times b is the same as the nth root of a times the nth root of b. Alright, then let's look at an example right here. The cube root of 16 times the cube root of 4. Instead, we can also say the cube root of 16 times 4. And now we can go ahead and multiply this. We get the cube root of 64. And now we need to break down the 64. And the way we did that in the past is by drawing a factor tree. Drawing a factor tree of the number 64 and break it down into its factors. 64 is 4 times 16. 4 can be broken down further into 2. I'm going to cross out the ones that we used so we don't get confused. 16 can be broken down into 4 and 4. And 4 again can be broken down into 2 times 2. So we end up with 6 2's. In other words, we can say 64 is 2 to the 6th power. And now we take the cube root of 2 to the 6th power, and remember also that we can group the 2's into 2 groups of 3, and we can take out the 2 twice. 2 times 2, nothing left underneath our radical, and 2 times 2 is of course equal to 4. Remember, we took groups of 3 2's at a time because we were dealing with the cube root. If it's the square root, we take pairs of 2, and if it's the fourth root, we take groups of 4. Alright, then let's talk about the quotient property, the other important property we have, and it's about quotients, it's about division, and what it says is the nth root of a quotient of a divided by b is equal to the nth root of a divided by the nth root of b. Now b, of course, can never be 0 because we cannot divide by 0. Other than that, everything is fine, and we can take the nth root of the numerator separately of the nth root of the denominator. Or we can even go back. We can go both ways. In our example here, we're actually going to go back and we're going to combine denominator and numerator to write the fourth root of 80 divided by 5, which helps us do some less work because now we have the fourth root of 16. And 16, as you will know if you break it down with your factor tree, is 2 to the power of 4. And if we take the fourth root of 2 to the power of 4, remember exponents and roots are inverse operations, and if they are raised to the same level, they cancel each other out. So our answer is 2. Our example on the right, we have to do something a little bit differently. We cannot take the 10 over 3 and simplify a fraction like that. And since we have a root in the denominator, we need to rationalize that denominator first. Now, how do we rationalize the denominator? Please note that we have cube roots here. So when we take our expression and we multiply it by a fraction, that will help us get rid of the radical in the denominator. We need to realize that we have a cube root of 3, and in order to be able to cancel out the cube root, we need the 3 to be cubed. So we need to multiply all this by the cube root of 3 squared. And of course we're going to do the same to the numerator, otherwise we would be changing the expression, which we're not allowed to do. Okay, then in the numerator we get the cube root of 10 times 3 squared, which is 9, so 10 times 9 is 90. In our denominator get the cube root of 3 cubed, and as we said and as we wanted, that will cancel each other out, and we end up with the cube root of 90 over 3. Let's talk about adding and subtracting roots. We can only add and subtract roots if the index and the radicand of both terms match. We can only add or subtract roots if the index and the radicand match. Index and radicand must match. In our first example, we have an index of 3 in both expressions and a radicand of 24. So we can go ahead and add these two terms, and we get 1 times the cube root of 24 plus 6 times the cube root of 24. That's 7 times the cube root of 24. And 24 broken down into its factors is 2 cubed, which is 8 times 3. 8 times 3 is 24. And again, you can do this by breaking your 24 down into a factor tree. And now let's see if we can simplify this any further. The cube root of 2 cubed, the two operations cancel each other out, so we can take out a 2 with nothing left underneath the radical. The cube root of 3 cannot be simplified any further, and so all we can do now is 7 times 2 is 14, and we get 14 times the cube root of 3. In our example on the right, the radicands match. Unfortunately, however, the indices don't. We got a 3 and a 4, and therefore we cannot do anything. We cannot add these two terms. That's too bad. Alright, then let's move on to multiplying roots. Multiplying roots is much easier because here only the index must match. Alright, then if we go ahead with our left example, we multiply the two numbers on the outside. Negative 3 times 2 is negative 6. And then we multiply the two numbers Underneath the radical, 12 times 18, and that's 216. And yes, you are welcome to use your calculator to do that. Can we simplify this radical expression any further? Well, we need to take the 216 and make a factor tree. Let's do this one together. 216, and when we get started, the easiest way usually is to just divide by 2. 2 times 108. 108 is 2 times 54. 54 is 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. So what we have now is negative 6 times the square root of 2 times 2 times 2 times 3 times 3 times 3. And yes, of course, you can write this with an exponent 2, but I want to go ahead and circle the pairs that we can pull out from underneath our radical. We can pull out 2 2's, and we can pull out 2 3's, and we end up with 1 2 and 1 3 left underneath our radical. Negative 6 times 2 times 3 is negative 36 times the square root of 6. And here is our final answer. If we need to multiply two expressions with subtraction or addition in parentheses, like in the example on the right, we just go ahead and FOIL them the way we would FOIL two binomials. Multiply the first by the first. Square root of 2 times square root of 2 is 2. Multiply the outer terms. We get positive 4 times the square root of 2. Multiply the inner terms. We get negative 1 time the square root of 2. And multiply the last terms. We get negative 4. We have some things that we can simplify and combine here. 2 minus 4 is negative 2. And 4 times the square root of 2 minus 1 times the square root of 2 is still positive 3 times the square root of 2. And here goes our answer. So much for now. Now go ahead and watch the second part of this tutorial.